All right, we're going to be assessing the toolbox engine. We do this once in a while, and this is also going to be a way for me to improve anything that's potentially not good about the current process. So the first process is we add the scripts submodule, and that's all that you really should have to know. And that's the first, I already made a mistake. This shows how to clone it, but we want to add it as a submodule. So we're going to do this. And once this is done, we have to have known that SBPT is the next program we want to use, and that we're going to add a sub. So scripts subproject main add source, and there is no source, and that's because we actually need to run the CPP project bootstrapper, and the CPP project bootstrapper is not even good yet, so I also need to add in some logic here that will make it so that I no longer have to always copy, run the preset. So this is an improvement phase, I guess you could say. So here we also want to add this logic and this logic. Okay, I'm happy with that. So now we're going to run Python scripts CPP project bootstrapper main, and we're going to, I guess, try interactive. So the Conan thing can be probably removed and replaced with the new method. But okay. So that gave us some code, and I want to assess the CMake lists that we got. Okay, that looks fine. And now we want to run the Conan utils, and this should be part of... Right, so actually we don't even run that yet because what we need to do now is add some sub-project. So sub-project main add into source, and we want the toolbox engine. So we just got the toolbox engine. That looks good. And now what we run is init source. And I want to see if there's a way to do init without having to every time specify yes. So I'm going to look at subproject, and I'm going to look for the init command and see what's getting called. So sbpt is init's being called, and it checks if the dependencies are satisfied, and it's gonna, right, okay, interactively add it. So if it doesn't exist, so if it's not a valid, there's no remote project, create a local one. I guess otherwise what? So if we get out here, then it is valid, and we can clone it. So we are about to add the following subproject, fetch file. So if there's no ini, if there's no tags, otherwise we have all the data. And I want to, right here's the main problem, because every time it's going to ask me, are you okay with this? Are you okay with this? And I want to make it so that it doesn't ask for confirmation sometimes. So we'll ask for confirmation. Ask for confirmation when when adding subproject. And to be honest, do we even need to ask yes or no? Like, when you run this, you're aware that this is going to happen, I think. So I think I'm going to not do this actually. So I'm going to just make a variable called requires no confirmation, and that's going to be true for now. And if requires no confirmation, we're going to do something. And otherwise, we're going to do this logic. So if it requires no confirmation, we just use the suggested do. And I'm hard coding that it requires no confirmation for now. That could be an option later on, but I think it's just better like this. Okay, so now we're going to do Python scripts subproject main init source, and we're just going to see what happens here. So it's just going ahead and getting all of the required things in order to make this happen. And like, the reason why yes and no here is probably not important is because nothing's gonna compile if you don't get everything that is a dependency. So it actually just does make sense not to really ask, I guess. And I think at one point it will ask me though, and that's when it's missing information. So sound types should come up soon, and it's gonna ask me to create it, I think. So we're getting a lot of stuff right now, and here we are at sound types. So we want to create a local subproject with this name, and where are we going to create it? We want to go into the sound directory, and I'm not sure exactly how this will work. This has always been confusing, but I'm gonna just do sound types, and then I'm gonna go into sound types, and I'm gonna select it. Yeah, and that's actually how it wants it to happen. And I don't actually like that. I think it should specifically say that that's what we're doing. So what happened there was when it's missing, you need to provide a path to where it should exist, and that should be said somewhere. So let's say that. So just for the next time this runs, oops. So create a local subproject with this name. So if that's true, I also want to say please create the directory where this subproject should exist. This is not the containing directory, right? That's specifically, I just want to make it so that people know that. And I also want to see this. So when you have a target dir, how does that work? We create that directory and then we want to create a subproject with the CPP boilerplate, blah, blah, blah. Okay. So creating a subproject just means creating source files and SBPT in that directory. So I'm going to write that down by creating HPP, CPP, and a SVT file .ini in the target dir. Okay, so I like that more. Yeah, I like that more. It's more obvious what's going on here. And now if we run tree on source, we can see that we have a bunch of stuff in here. And that's actually good. We want all that stuff to do what we need to do. So the next thing is, how do we do anything at all with this? Right, so, well, the first thing is maybe we want to make sure stuff builds. And in order to make stuff build, we need something to happen. We need to get the packages that are required here. And this is a step that should automatically happen, I think. And it should be packaged into the Go script, which isn't very good. So Conan utils client generate. And what I'm doing here is I am generating a Conan file with the required packages. So if we look at my Conan file, this just got created. And now I want to run Conan install. So I'm getting all of my required packages to make this happen. And Conan's also giving me some code to statically link my libraries into the executable, and I want to do that. So I need to go into my CMake list and paste this at the bottom. And I'm going to use project name here. So now, if I run CMake preset, Conan release, CMake preset, Conan build this time, this should hopefully all just compile and work. Unless, right, okay. Always add a little quick unless in there, so, you know. So another step needs to occur, which is we need to generate the batching systems. And why do we need to generate batching systems? We need to generate batching systems because OpenGL's API for version 3.3 is not that good. In terms, it doesn't have the GL draw instance or sorry, GL multi-draw deferred, not deferred, but there's like one that like allows you to build up things to draw and then draw them all at once. And we need that in ours. So let's do that. And this can just be pretty much thought of as the the batching system. It batches against your shaders that you use in your program. And this probably isn't the best solution. Maybe they should already all exist and then only somehow use what's required, but for now we have to do this. So what we're going to do, and this is part of the assessment, this part is not the best. So we're going to set up our graphic systems. Shader complement. Okay. And here's another issue, which is that when you run that script, oh, we don't even have the assets directory. So the assets directory it should exist because someone needs it. And it's not coming in, so we have to add this manually. So that's something that should be automatically done. So, oh, my brain just kind of broke there for a sec. What we need is shaders. So we're gonna grab our shaders here, and we're gonna make a directory. And what next? We're gonna add our shaders here. Now, if we set up our graphic systems, we still have a new problem, right? There are sub-sub modules that aren't being dealt with. So in order to get all of those submodules, I need to refer to this because I forgot how. So for each submodule, we need to update them and initialize them recursively. So we're going to do that. So as you can see, it just got the batcher stuff. And this should happen during SBPT and knit. This is bad that it's not happening. But either way, we have that now. And now if we set up our graphic systems, we got the absolute position with colored vertex. And I think we should also probably get another one. And here's where another specific piece of knowledge exists that has to be known, which is that the required shader batchers file. And how do you even know like what is the syntax for that as well? That needs to be in a place that's very easy to access, because right now what I have to do is I have to go to like shader cache and or is it even shader cache? Maybe it's like shader standard. I'm kind of even lost when it comes to that. Let's go to the cache and we have to figure out where the types come from. Shader standard.hpp. Okay. And these are all of the shaders we currently have. And one of the shaders we want to use is I think it's going to be I think it's just going to be absolute position with colored vertex. I think, no, I want to use colored vertex, but I want to use it with the uniform buffer object where we store our transformation in it. So I'm going to use this, and I use the shader type inside of the required shader batchers file, just like this in lowercase. Okay, so now we've set it up. So if I run my graphic systems, you'll see that we now get the additional shader here, which is what I want. Okay. Now if I go to source main, the one major downside now, well, before talking about downsides, let's talk about some good things. I want toolbox engine, and so I just have to go to system logic, and then I can go to toolbox engine, and I can bring in the toolbox engine. And now that I have the toolbox engine, I can do toolbox engine, tvx engine, because that's a little faster. And I need to look at the constructor for it, right? So what is the constructor for this? The constructor, and this class should be a little better organized, and also sound type doesn't exist, right? So sound type needs to be generated, and it gets generated by the sound files in this. And in terms of the sound files that we need, they are going to be an easy way to get them for me is going to be via this. So I'm going to go to I'm going to open up a new tab. And then what we have here is going to be our sounds. So I'm going to copy the sounds, and I'm going to go into the zombies. And if I go into the assets, I'm going to paste the sounds. So once I've done this, this is bad. I had to go somewhere else on my local file system to fetch these. So these should be stored in like probably the menu because that's like where they're coming from. But now we have the sounds, and if I run tree asset sounds, we can see that those are there. And now we run Pi scripts setup sound, generate sound types, error, and then the audio dir is assets sounds relative to the home directory. And it created this, and I'm gonna copy the sound type, and then I'm gonna go and then source main, SF sound types, and I'm gonna paste this in here. And now I'm gonna go back to main. So now sound types should exist. And now we need to construct this properly. And the constructor for this is not the best right now. It takes in the program name, the requested shaders, which we've also already specified via that file. So that should not be like having to be passed in like this, in my opinion. I think it should be dynamically constructed from that file. But whatever, it's a little bit of redundancy, and that's just how that is right now. But the sound type to file thing, I guess that could also be dynamically generated and put into its own, I guess HPP file. I think that's probably what I'd do for both of these. Either way, that's not how it is now. Everything is in the slow process of moving towards how it should be. And that's just how engine development goes. It's never perfect because you're always wanting to make progress. And sometimes the fastest way of making progress is to do stuff a little bit sloppily because you can get it done now rather than tomorrow. Okay, anyways, we generated the sound type map was here. We can copy that, and then we can paste it above here. And for the requested shaders, we're gonna create a vector of shader type. And this is the requested shaders, and it's equal to, I think we have absolute position colored vertex, and then we have CWL with colored vertex. I think that's it. So this is a very minimal way, and then again, looking at the constructor, we need the program, the requested shaders, and then that. So I'm gonna just call this zombies, and then we have requested shaders, and then the sound type to file. And there you go. So this created the engine. We need to run it, and the way we're gonna run it is we're gonna do a function which is tick, and it's a function that takes in dt. And what are we gonna do? What we have to do now is we want to render the menu that comes with the toolbox engine, and so tbx engine dot process and queue render input. We're gonna do this, and we're gonna capture that by reference. And this is already like just to do the menu, whatever. At least like you can. The one thing with engines is it's kind of nasty when the engine is doing a lot of stuff without specifically telling you or having an option for it. So even though this is out in the open, I don't care for now because it's like if you want to render the menu, then just do it, right? And it actually won't do it unless the menu is active. So there is some logic to not just be drawing it. Like it will take care of itself to a certain extent. So we have this input graphics sound menu here, and that will queue it. It doesn't render it, but it queues up the geometry to be rendered. And then what we do is we use the TBX engine batcher, and then this one is the absolute position with colored vertex shader batcher, and we do queue draw. No, it's draw everything. And let's just see like what we get with this. So TBX engine dot start, and it takes in a rate limited function. It takes in a termination condition function, and I actually want to automate that out because a decent one should be just the function that returns window should close. So what I'm going to do here is I'm going to make a this thing. Non-local lambda expression cannot have a capture default. Right, that does kind of make sense. Maybe I'll just make this an optional then. So a const reference to a function that returns a bool, but instead it's an std optional. And the default value is null opt. So with this, we're going to call start again. But what we're going to do is we're actually going to define it here. So I'm going to call this std function bool that takes in nothing. And this is going to be the real termination. And what is this? So if termination condition function is there, we're going to do term equals to the actual value inside of it. Sorry. Otherwise, and I can use value or here, but I'm just doing this because it's simpler for right now. Otherwise, term equals a lambda function That's going to capture, I guess by that, we're capturing this, because then we're going to just return window should close here. And let's see if this works. So now term is guaranteed to be defined. And I could have used value or, but whatever. Eh, I'll do it. So termination condition func dot value or. So it's either going to be the value or it's going to be this lambda. That's a little cleaner. And then here we just pass term. So now in main, the API is a little cleaner in that all we have to say is tick. So now it's just going to run this over and over again. And I have no idea if this will run first try, but let's hope it does. So I guess I'll just double check on how long it's been since the start. So it's been around 30 minutes. So 30 minutes to create a new project, kind of long. I've also been explaining things and doing minor improvements, but it should be better than this. But it's not the worst thing, right? It's not the worst thing ever. You're getting a full minimal working 3D engine where you can play sounds, you can render things to the screen, you have a menu to switch on some graphical options. So, yes, this could be better, but it could also be worse. And what you get out of it is pretty good for the effort we put in. In reality, that whole process should just be like a big a big red button or a big button. You just smack it, and all of that stuff that was manually done by me should have just happened. And yeah, we're just building this out now. Great. So why did that happen? I need to go push Matthew Tills really quick. Okay, so this problem, I'm actually glad this came up. This is happening because we don't have versioning within the sub-projects yet. When the sub-projects have versions and they depend on other versions, then this is a problem we can fix. So the problem is specifically there's a new entry in the API and this vertex geometry file is using it and it fails because it didn't get the newest version. So it depends on on the newest version, and in fact I hadn't even pushed it on that. So that's a pretty big mistake on my part. But source math utility math utils git pull, go back, let's try it again. There might be other changes that I'm not accounting for, which I'm kind of afraid of now, but let me see what's going on here. So GLM utils, math utils, mesh utils movement. I think most of that's relatively okay. I'm a little afraid of GLM utils messing things up, but we will see. Hopefully this compiles. And I could have built with debug to make this a little faster and reduce the optimizations, but I decided not to. We're already on main. Another thing about making your own engine, which I kind of like, is, well, when using an engine too, and it's a C++ thing, I'm not locking you into doing anything. The engine is just a utility to do things faster. So when you're in main, and if you look at main really quick, this tick in this start, if we look at what start does, it just wrapped the logic with the GLFW logic to like clear the buffer, and then at the end, all it did was run like swap buffers and pull events. And so you don't even have to use the start function. That was just something that I made where if you do end up using it, then you will get to stuff on the screen faster. And that's the only reason. Like if you wanted to do it completely differently, I'm not gonna force you through the engine. The engine is only there as a utility to make your life better, and you can decide to adhere to that or not. Okay, so that's funny. Nothing shows up, and that's fine. Let's understand why nothing showed up. Error, unable to open config file, glad successfully loaded. Starting shader cache, ending, binding. So in my mind, right, okay. I actually know why this happened now. And the engine should really warn you about this. So the shader that we're using for the absolute position with the color vertices, it requires a few things. So if we go ahead and look at it, and if we look at the vertex shader, it takes in a position and an aspect ratio. And if the aspect ratio isn't there, we're not going to see anything because I think it's just initialized to the 0 vector and it crunches all the geometry down to the origin. So that's probably what's going on here. And there should have been a big red warning saying not all like there is a shader uniform that has not been set yet. So that's something that should happen, but didn't, and that is bad, but it's current state of things. So TBX engine shader cache dot set uniform, and shader type, we're doing it on the this one up here. And in a way, I wish it would only allow me to do stuff that was actually possible. I could have used a shader type that's not even initialized there, and that's a big problem because this is just an enum of all the different shader types. Nonetheless, the uniform variable should be the aspect ratio. And again, this should not be accessed like this. This should be part of like the logic that looks at the shaders and generates source code should also look at the shaders that were requested and only generate things that were actually needed. But anyways, what we're going to do here is get the toolbox engine, and we're going to get the aspect ratio. So window.aspect in simplest terms, and that's going to return us, what is that going to return? A tuple of unsigned ints. And we need to turn this into a GLM vec2. Also kind of nasty, but I don't care. So I need to bring in my GLM utils here. So okay, so with that I can do something like not GLM utils, is it? Tuple? Yeah, tuple to vec2. Okay, so now that's the correct type. So now if we build this and we run this, this should work. So when we turn this on, we should hope to see a menu. Okay, so that's funny. Uniform not found in this. Oh, okay. That does make sense. I messed up the shader type. It should have been the first one. So at least it's telling me that it doesn't exist. So that makes sense, and I can fix that. A minor error. But again, you shouldn't even be able to write something that's wrong. And that would be enforced by constructing a shader in the code for each shader program that we write, which is the collection of fragment and vertex shader things. And then we get like a C++ kind of like empty data representation of that we can use. So I couldn't have made that mistake in the first place. That would be the better approach. But the thing is, all of this stuff works and gets you off the ground fast. And that stuff will get fixed when I have made stuff that is worthwhile with this. Okay. So yeah, this is good. Again, there's no sound happening on the menu, and also there's some printing going on. So what do I want to do? I just want to play the sounds first of all. So tbx engine.sound system.play all sounds should work. And I'll just start building that. And what else? That should give me a working menu. And that's kind of where I want to cut it. Once that compiles and once I see that menu and I can interact with it, at least to a point where it's clear that we can progress from here, that's kind of where I want to stop it. We'll just make sure that's the case. Maybe I'll get like a rectangle, a red rectangle on the screen too. Or like, yeah. Actually, no, I'm not going to do that either. Just want to see the menu, because that's the minimal working thing. Alright, that's great. Graphics, go big. Full screen on, sure. Wireframe, we can see what that looks like. There you go. Anyways, there you go. Working program from scratch, toolbox engine. Took a while, but that's the current status.